Counting problems are really old math problems, and they go all the way back to ancient times. They are not easy, but appear frequently in the GMAT. This video is an introduction to counting problems, helping you get solid concept of counting, permutations, and combinations. When approaching counting problems like how many ways are there or how many groups can be formed, remember these four things. First, always break down steps and solve individual steps. Don't skip process because that will make you fall into traps. Second, rather than depending on formulae, focus on the concept. Usually it's a good idea to count from the whole picture and then count the specific details and then multiply or add all possible outcomes. Third, ask yourself for every question, is the order important? If the order is important, use permutation. If the order is not important, use combinations. Fourth, do you have identical elements? If you have identical elements that are not distinguishable, use permutation. In other words, permutations are used for the same kind items. If you need to refresh factorial, permutation, and combination concepts, I will help you YouTube lecture videos in the description below. This question is an easy GMAT question, about 411. There are three groups labeled A, B, and C. Groups A and B have 8 people, and Group C has 16 people. All groups have no people in common. A new group is to be formed by selecting one person from Group A, one person from Group B, and 2 people from Group C. How many different groups can be formed in this way? Let us break down steps. The first step is asking yourself if order is important. Is the order important in this question? Not really. Because order is not important, we use combinations for this question. The formula for combinations is n factorial divided by n minus k factorial times k factorial. The variable n refers to total possible number and k refers to number of selected ways. The second step is selecting one person from Group A and another person from Group B. If you are to select one person from 8 people, how many ways are possible? There are 8 different ways to select. In combination, this is 8C1. Using this formula, it ends up with the number 8. That's right. If you have a k as 1, then the equation is always equal to the total number n. For example, 10C1 is 10, 20C1 is 20, and so on. So we can select 8 ways for Group A and another 8 ways for Group B. The third step is counting number of ways to select 2 people from Group C. There are a total of 16 people in Group C. Then we have n equals 16 and k equals 2. 16C2 equals 16 factorial divided by 16 minus 2 factorial multiplied by 2 factorial again in the denominator. Then we have 16 factorial divided by 14 factorial 2 factorial. 14 factorials are cancelled out in both the denominator and numerator, and we have 16 times 15 over 2. Simplifying further, we have 8 times 15, which is 120. Now that we got number of possible ways for each group, the final step is multiplying all possible ways. We multiply these numbers because the selection is joined by the word and. We select one person from Group A and one person from Group B and 2 people from Group C. If you see the word and, you should multiply. On the other hand, if you see the word or, you add the numbers. For example, if a question is asking how many possible ways are there to select one person from Group A or one person from Group B, you add these numbers. Because we see the word and in this question, we multiply all numbers. 8 ways times 8 ways times 120 ways. The answer is 7,680 ways. Now, this is the GMAT. Are you actually calculating the multiplication going through all steps? Don't. A quicker way to approach multiplication is multiplying the last meaningful digit for each number. 8 times 8 produces the unit digit 4 from 64. 4 times 120 produces 80 for the last 2 digits. So select the answer choice that has 80 for the last 2 digits, and D is the only one with 80 at the end. D is the answer. Let us look at another 411 GMAT question. If 8 people meet at school and each person high-fives exactly once with each of the others, what is the total number of high fives? When you do a high five, you don't high five alone. It takes 2 people to high five.
Fraction 5! What on earth?
The order does not matter, so use a combination. Out of a total 8 people, 2 people are selected to high five. So it is 8C2. 8C2 is equal to 8 factorial divided by 8 minus 2 factorial multiplied by 2 factorial. It is equal to 8 factorial over 6 factorial times 2 factorial. We cancel out 6 factorials in both the numerator and denominator, and we have 8 times 7 divided by 2. Simplifying it, we get 4 times 7, which is 28. The total possible number of high fives is 28 ways. The answer is C. In this problem, figure out what it means by reading carefully. There are 7 boxes in this play. Of the 7 boxes, 4 are yellow, 2 is white, and 1 is green. The boxes are identical except for colors. How many different display arrangement of the 7 boxes are possible? We can see that boxes of the same color is identical. For example, we have 4 yellow boxes that are identical. Because we have identical elements in this question, we can use permutation. The formula is like the following. Total number of possible ways of factorial divided by factorials of the same kind. There are 7 possible ways, 4 identical yellow boxes and 2 identical white boxes. So the equation would be 7 factorial divided by 4 factorial times 2 factorial. We can cancel out 4 factorial in the fraction, and we have 7 times 6 times 5 divided by 2. This is equal to 105. The answer is E. So remember 2 things. Is the order important? If yes, use permutation. If no, use combinations. Are there identical elements? If yes, use permutations. Only when you are comfortable with factorials, combinations, and permutations, you can solve it beyond 500 level questions. Don't forget to subscribe and like the video, and good luck with the counting.